Yeah, we'll do some questions. So write down one question. In a pure silicon crystal, we'll do one question. Write down. In a pure silicon crystal, write down in the notebook. In a pure silicon crystal, there are 10 raised to 13 electron hole pairs per meter cube. Electron hole pairs per meter cube. If 10 raised to 19 phosphorus atom mixed per meter cube in a crystal, then find the nature of the semiconductor. Nature of the semiconductor, number of electrons, number of holes, and total charge carriers. Read the question. What are the things which are given in the question? In a pure silicon crystal, so it is an intrinsic semiconductor, has 10 power 13 electron hole pairs are present. Okay, 10 power 13 electron hole pairs are present means that is called intrinsic concentration. Correct? That's what we have learned, right? In a pure semiconductor, we know it is an intrinsic semiconductor. Electron hole pair concentration is, how much is given? 10 power 30. Electron hole pair concentration in an intrinsic semiconductor is equal to what? Intrinsic concentration. That is given as how much? 10 power 30. So we'll solve it step by step. So answer it. Okay. In a pure semiconductor, electron hole pair, right? In a pure semiconductor, step by step, very detailed way. In a pure semiconductor, electron hole pair concentration is equal to intrinsic concentration. This is what we have learned from the theory. Intrinsic concentration. Correct? It's called intrinsic concentration, which is equal to Ni. This is what I know. Which is equal to Ni. Ni means Ni is equal to what? Ni in the question. Ni is equal to what? 10 power 13. Ni equal to 10 power 13. So first sentence is over. What is the second sentence in the question? If phosphorus is added. Okay. Phosphorus is added to where? 10 power 19 phosphorus atoms are added per meter. One meter unit 10 power 19 phosphorus are added. Phosphorus is adding. Okay, so how much is the concentration of phosphorus? That I know, that is called donor concentration. Okay, because phosphorus is in which group? 15th group. So donor concentration is equal to 10 power 90. These two informations are given. Next we look into question, what are the things we need to find out. First one, nature of the semiconductor. So you can write N is equal to 10 power 90. Nature of the semiconductor is what type of semiconductor? N type. So I know the answer is N type semiconductor. N type semiconductor. Reason is phosphorus is added, 15th group element is added. Second part answering. What is the second part? Number of electrons. How to find out number of electrons? Number of donor is equal to number of electrons. Correct? Number of donor is equal to number of electron, which is equal to 10 power 19. Correct? 10 power 19. Third part of the question. Number of holes, NH. How should I find NH? Ni square is equal to Ne into NH. We'll substitute here all the values. Ni square. So 10 power 13, the square is equal to Ne 10 power 19 NH. Continuing here, 10 power 13 the square 10 power 26 is equal to 10 power 19 into NH. So NH will be equal to 10 power 7. So that also calculated. Fourth part of the question is what? Total carriers. Total carriers means what? Total carriers is equal to majority carriers plus minority carriers. So majority carrier plus minority carrier. Minority carrier. What is a majority carrier? Number of electrons. Minority carrier, number of holes. Number of electrons I know. How much? 10 power 10 power 19, right? Holes is 10 power 7. 10 power 7. So write as 10 power 19. Because 10 power 19 and 10 power 7 compare 10 power 19 is very high comparable to 10 power 7, right? So approximately 10 power 19 you can write like that, or you can solve it also, no issues. But I'm saying this is a very higher value, this is a very lesser value. 7 into almost 3 ആണ്. 7 into almost 3. So 10 power 19 were 10 into 18 zeros. 10 into 6 zeros. So comparable to that, this is a higher value. So approximately 10 power 19. Okay. So total carriers, majority carriers plus minority carriers, Ne plus NH will be equal to so and so. Okay. Understood? All the 4 question answers. So let's go to the next one. In a germanium crystal, right? Next question. In a germanium crystal, there are 6 into 10 power 21 atoms. In a germanium crystal, there are 6 into 10 power 21 atoms per centimeter cube. Per centimeter. And number of electrons at room temperature is 10 power per centimeter cube. 10 raised to 11 per centimeter cube. Full stop and continue. If indium, right? If indium is added in germanium crystal of concentration 5 ppm. ppm means parts per million. Bracket like the parts per million if you don't know. 5 ppm. Then find the nature of semiconductor. Ne, NH and total carriers. Ne, NH and total carriers. Read the question and understand what we need to find out. This is different from the previous one, but there is a slight difference, not major difference. In the previous question, what it is given? You have to connect and study. What are the things in the previous question given? Silicon hole concentration, or simply we can say electron concentration is equal to hole concentration. That is something called the intrinsic concentration. Ni is given and Nd is given. Nd is equal to Ne. We can calculate NH also. This is what we have done in the previous question. But what is given will be here. Here number of in a germanium crystal, number of atom is equal to 6 into 10 by 21 atoms. Okay, so write the first heading. We will not the first step. Number of germanium atom is equal to, we'll solve it step by step. Number of germanium atom is equal to how much? 6 into 10 power of 21 per centimeter cube. Okay, so per centimeter cube, I'll put it like this, 6 per. Okay, so that is written, nothing to derive from there. What is the next sentence? At room temperature. So this is all about pure germanium. So number of electron is equal to number of holes is equal to intrinsic concentrations in a pure conductor. So I can written like this one, Ni equal to 10 power 11 per centimeter cube. Correct? Because they are not talking anything about the doping now. Next sentence. What? If indium is added, now it is going to become what? Extrinsic. If indium is added, how much? 5. It's adding what? 5 ppm, parts per million. What is the meaning of this one? Parts per million, the meaning of this one means indium 5 parts per million means atoms. Listen very carefully, then later you can write 5 atoms of indium added to the meaning added to 10 power 6 atoms of germanium. Okay, 5 atoms, just 5 atoms are added 10 power 6 atoms of germanium, or I can, in a reverse way I can say 10 power 6 germanium atom have how many indiums? 5 indiums. Okay, 5 indiums. Okay, 5 indium atom. I have to write 5 indium atom. 10 power 6 germanium atom, 5 indium atom. So one germanium atom will have how many indiums? 5 divided by 10 power 16 indium atom, correct? So how many germanium atom totally? 6 into, so which means 6 into 10 power 21 germanium contains how many indium? 5 into 5 divided by 10 power 6 into, this is for one germanium. Now we have how many germanium? 6 into 10 power 21. Multiplied with 6 into 10 power 21 indium atom. Okay, by calculating this one, how much will you get? 5 into 6, 30. 30 into 10 power 15. 13 into 10 power 15 indiums are present in the whole this one. Correct? 6 into 10 power 21 germanium atom contains 30 into 10 power 15 what atoms? Indium atoms. So for understood, so write it up to this. It's not completed. We have to complete it further. So number of indium atom in 6 into 10 power 21 germanium atom is equal to 30 into 10 power 15. This indium atom, the concentration of indium is which group element? 13th, right? Boron, aluminum, gallium, indium, thallium. So this concentration of indium is an electronic concentration or whole concentration? This is whole. So this is nothing but NH will be equal to 30 into 10 power 15 per centimeter cube. All are in centimeter cube. Okay. So 30 into 10 power 15 per centimeter cube. 30 into 10 power 15 per centimeter cube. So number of holes I got, number of intrinsic concentration I got. Next what I need to find out? Number of electrons. So what is the first part? number of electron. Ni square equal to Ne into Nh. Ni square 10 power 11 square 10 power 22. Ne number of electrons I don't know, number of holes I know, 30 into 10 power 15, 15. So what should I get? Ne equal to 1 by 30 into 10 power 7. 1 by 3 means 0.33 into 0 cut. So 10 power 6. 0.33 into 10 power 6. Correct. So this can be written as 3.33 into 10 power 5 also. Simplify nothing else. 1 by 3 then 0.33 into ഇവിടെ ഒരു 10 ന്റെ ഒരു 0 യും ഒരു 0 യും ക്യാൻസൽ ആയി 10 power 6 ഒരു 6 ഒരു 10 മൾട്ടിപ്ലൈ ചെയ്തു. So 3.3 into 10 power 5. Okay, so number of electron is this one, number of holes we got. This is what type of semiconductors? P type. So next one, this is a P type semiconductor. This is a P type semiconductor. Okay, now can you tell me what is the difference between the previous question and this question? In previous question, the concentration of phosphorus, it's the complete concentration of phosphorus is given there, correct? Complete constant. So directly we have taken what? Nd is equal to Ne. But here we cannot take 5 parts per million directly as NH. Why? Because 5 parts per million means 5 atoms are present in 10 power 6. We need to know how many atoms are present in 6 into 10 power 21. That we have find extra here, then we got NH. Then from here it is similar to the previous question also. So the only difference means here the concentration will be given 5 parts per million unit. But in the previous question, what is the unit will be given? Number of phosphorus. Number of phosphorus is how much given? Correct. Number of phosphorus value is given, but that number of phosphorus value is completely into the complete silicon. But here it's not like that. The 5 is only for 10 power 6 atoms. So for this many atoms we have to find how many holes will be there. Then intrinsic concentration I know, holes I know, I find out electronic concentration. One more part will be the total charge carriers. What is the total charge carriers? So total charge carriers also solved. Total charge carriers. Total charge carriers in the question. Ne plus NH. Ne plus NH. Ne means what? Here. 3.3 into 10 power 5 plus NH. NH is this one, right? Okay. So 30 into 10 power 15. You can keep it like this one. If you want, you can solve it. Nothing else. Nothing wrong. Nothing. Okay. So 3.3 into 10 power 5 plus 30 into 10 power 15. Okay. All these questions will not ask, but any one will ask. Okay. Mostly this is what type of semiconductor will never ask. Okay. That everybody will know, right? Mostly they will ask number of electronic concentration. Because this only the work is there. So they will ask this one, or they will ask the last one also. Okay. We'll do one more questions. Write down. The concentration of the next, the third question. The concentration of electron pairs in a pure silicon at 300 Kelvin. That means in room temperature at 300 Kelvin, 7 into 10 power 15 per meter cube. Antimony is doped into silicon atoms assume that antimony is doped into silicon atoms. Antimony is doped into silicon atoms. Assume in a proportion of 1 atom in 10 power silicon atom. 1 atom in 10 power silicon atom. 1 atom in 10 power 10 raised to 7 silicon atom. 1 atom in 10 power 10 raised to 7 silicon atom. Assume that half of the impurity atoms contributing to conduction. Calculate the factor by which number of charge carriers increases. Calculate the factor by which number of charge carriers increases due to doping. Full stop and then continue. Number of silicon atoms per meter cube is equal to 5 into 10 power 28. 5 into 10 power 28. Perfect. So read the question, how to solve it. Based on the experience of the first question and second question, combined knowledge can solve this one. So read the question, what all the things are given and how we will proceed. Step by step we will write it. Now what is the first sentence is given? Concentration of electron in the crystal is how much? 7 into 10 power 15. That is called what? Ni means intrinsic concentration. Electron hole pair concentration is called intrinsic concentration. So Ni equal to, how much is the value? That value. Okay, let me write. Give me a couple of minutes. I'll clear the board. So question, not only this one, doping related problems. Question, the difficulty is we have to identify what is Ni, what is Ne, what is NH. That is a difficulty in this question. If you are able to identify that successfully, 50% you are answered. Okay, so what is Ni given? 7 into 10 power 15. So intrinsic concentration is given. So we identified that. What's the second statement? Antimony is added. So this is which group element? 15th group. So definitely it become what semiconductor? N-type semiconductor. So next point. So what we got? Antimony is the dopant. Antimony is the dopant. Semiconductor. This is the second invention, right? N-type semiconductor. Antimony is added. What portion it is added? 1 antimony atom is added to what? How much? 10. So nothing to do there. We stop there. What's the third sentence? Assume that half of the impurity atoms are contributing to current. What is the meaning of this one? This antimony, the total number of antimony atoms is called what? Donor impurities. Previously we told donor impurity is equal to number of electrons. Now in the question they told half of the donor impurity is contributing to current, which means number of electron is equal to Nd divided by 2. Okay, half of them will be contributing because I want the number of electrons. Previously I assumed every donor impurities are contributing to current, but now the situation is not like that. The question is specific, half of them is contributing to current, means ND/2 is equal to NE. Okay, come, next point is what? Next sentence from the question. How much is the charge carriers which is increased due to doping? That is a question we want to be find out. One more hint is given, right? Number of silicon atoms, total number of silicon atom is equal to how much? 10 per 28. Okay. What I will do next? Yeah, what I want to do next? Total antimony I have to find out. But what is given? 10 power silicon will have 1 antimony. Okay, correct. So I'll write down 10 power silicon I have 1 antimony. 1 antimony, 10 power silicon. So 1 silicon I have how many antimony? 1 divided by 10 power 7 antimony atoms will be available. Next, what is how my number of silicon atoms? 5. 5 into 10 power 28 silicon have 1 divided by 10 power 7 into 5 into 10 power 28, which is equal to 5 into 10 power 21 antimony atoms. This is what? What is this number is called? ND. This is called the donor impurity. Donor impurity. Correct? So I got ND, I got NI, NE. NE is what? NE is given by second hint. Correct. NE is equal to ND divided by 2. So 5 by 2 into 10 power 21. 5 by 2 means how much? 2.5 into 10 power 21. So NE I got. Okay, slightly difference between slightly difference. Earlier we have taken ND is equal to ND, but now it is given as half, so we got NE. Next, what we want to be find out? NH. So we'll find NH. So Ni square equal to Ne into NH. Ni square, this is the square. So 49 into 10 power 30 is equal to Ne. 2.5 into 10 power 20 into NH. How much NH will come? Tell me an approximate value.
2 into 10 power 10.
49 and 15 will come. Easy at simplicity. Okay. 49 I am assuming as 50. So my calculation will be easier, like 50 divided by 2.5. So this is approximately equal to 49 divided by 2.5 into 10 power 9. So I am considering this as approximately 50 divided by 2.5 into 10 power 9. 50 divided by 25 is 2. So 20 into 10 power 9. Approximately, simple equal to approximately 20 into 10 power 9. This is number of holes.
10 power 8.
10 power 9 then? Cut. 20 into 10 power 9. Now you see, this is what type of semiconductor? N-type semiconductor. See the number of electrons, 2.5 into 10 power 21. Number of holes is how much? 20 into 10 power 9. So which one is higher? Electrons will be higher, holes will be lesser. Okay, all are in the same page, right? Okay, next, what is the question? Calculate factor by which number of carriers increases. Evlo factor increase aayunnallathu 2 times increase ayo, 3 times increase ayo, 4 times increase ayo adu kandupidikkanam. Adukku how we will do? We need an initial concentration. So how we will find the increase? For example, suppose I have written exam, I got 50 marks out of 100. Okay, another guy written examination, he got 100 out of 100. Okay, I can say he is double than me, 2 factor. Okay, is double factor. So what makes the difference? The numerator makes the difference. Denominator will be the same. Basic mathematics I am talking. Correct. So what makes the difference will be here means here I can say it is like 50%. Here I can say it is like 100%. Or I can say here it is 1 by 2. Here is equal to 1. Okay. Here he got 50 out of the maximum value. Correct. In school we learned about eta, efficiency of Carnot engines, or efficiency. How you will find efficiency? Output by input into 100. What is output? Output means, for example, this 50. You have an exam for 100. Which means I taught you for 100 marks, but you are written only for 50 marks. Then only you got 50 by 100. So your output is, what you produced is 50. What I have given to you is input. Okay. So this output, can I define it in another way? Output I am defining it. For example, the mark I am taking 25 divided by 100. What you get it will be here 25 mark. How much you lost here? 75. So this output I am representing as input minus loss divided by input. Input minus loss by input. Okay, input minus loss divided by input. Both are correct, right? Input minus loss is your output. So this efficiency can also be represented in one way. Or while we are finding the factor, input is the higher value. Loss is the initial value. Correct? I mean, input is always the higher value. Loss is always lesser. Input and loss higher gone 0. Okay, input and higher input and 100 marks. You can maximum get 100. You will never get more than the denominator. So input is the higher value. So input I am representing as intrinsic concentration. Input I am representing as intrinsic concentration. So here input minus loss, which means I got something. Now before doping my concentration is what? Intrinsic concentration. After I am adding impurity into that, what will happen? Charge carriers are improved. So that is called the final concentration. Okay. So final concentration minus initial concentration is what? This is what is the effect. Final concentration minus initial concentration, in the sense, in a simple way, I'll say I have initial electrons are there. I have 100 electrons are there. Now I have added antimony atoms. Now I'll got 200 atoms. Okay. Now I initially how much atoms will be there? In a simple way, 100. Now I added antimony atoms. I got how much? NF will be equal to 200 atoms. Can you say how much factor it is increased? 2 factor it is increased. You are saying 2 factor. I'll take another example. I am saying Ni will be equal to 50 atoms initially. Now after adding the dopant, NF will be equal to 400. How many times it is increased? How you got 8 from this one? Because NF minus Ni. Okay, NF minus Ni is how much? 350 is coming. NF minus Ni. But this is a multiplication factor. How much factor it is improved? So you have to find the final concentration. You have to find out the initial concentration, and other evolve time you have to check. Correct? That is the thing. So how to find out this Ni is given in the question. N is how much? So equal to okay, now I am writing initial concentration. Initial concentration. Initial concentration means what? Before doping. Doping illa. So before doping, the initial concentration is equal to Ne plus NH. Correct? Number of electron plus number of holes. What is Ne? Before doping, Ni plus Ni. Before doping, both are same, right? We have written Ne equal to NH. All are same. So Ne plus NH returns Ni plus Ni. Ni plus Ni means 2Ni. 2 into Ni. 7 into 10 power 50, which become 14 into 10 power 50. This is the initial number. 10 power 50. Next, final concentration. Final concentration is what? After doping. So final after doping, final concentration after doping, how much it's coming? Again, number of electrons plus number of holes. Now both are not same. Now it is changed after doping. Number of electrons after doping? 2.5 into 10 power of 21. 2 power of 21 plus number of holes is how much? 20 into 10 power 9. Again, this is small number, this is a higher number. Correct. Number of holes is, number of electrons are very higher comparable to number of holes. So this is approximately, simply change equal to the simple change 2.5 into 10 power 21. I neglected this, comparable to 10 power 21, 10 power 9. I neglected this one. So I got the first factor. So this is the after the concentration. Before is the concentration. 14 into 10 power 15. 2.5 into 10 power 21. This is a final constant. So right, then we'll continue. This is clear, before doping, after doping. In doping பண்ணதுக்கு முன்னாடி, this contains 14 into 10 power of 15 atoms. After doping, 2.5 into 10 power 21. So before doping, after doping. So how much is given by the dopant? Before doping ஒரு நம்பர் இருக்கு, after doping ஒரு நம்பர் இருக்கு. So before doping, for example, before doping I am seeing like 100. After doping I have seen like 150. How many given by the dopant? 50. How you got that? Difference between them. Okay, so below, right, the next one. The concentration of carriers, the concentration of dopant, we can put it like this one. The concentration of dopant is equal to NF minus NI. This is a final concentration. Okay, the concentration of dopant is equal to NF minus NI. This much dopant is improved, correct? Final in the initial, this is a different. So the difference between these two is the extra given by the dopant. How to find the percentage or the factor? Factor is equal to NF minus NI divided by, with respect to what we'll calculate? With respect to initial value. With respect to initial value, we are calculating, right, everything. So NF minus NI. 2.5 into 10 power of 21 minus 14 into 10 power of 15 whole divided by 14 into 10 power 15. This is the factor. Okay, look into the question. What is the last sentence? How much is the, first complete, then look into the question, then we'll confirm it again. Okay, what's the last sentence of the question? What is the question? What the question is asking? What is the factor? Number of charge carriers increases. Factor due to which doping. Because of doping, how much is the charge carriers are increased? Increased in Ketina NF minus Ni. NF minus Ni quantity increased. How much factor? Factor in Ketina with respect to initial value. Meaning. With respect to initial value. With respect to initial value means divided by Ni. A factor is a word here Ni. How much is increased if question is asking and stopping like that? The carriers are given by the dopant is equal to NF minus Ni. The factor with respect to initial level NF minus Ni divided by Ni. All these three questions understood. This much complexity will not ask. There is a less chance. But of course, you know, in a paper there is some rank deciding questions will be there. Correct? Easy questions irukum, average level questions irukum, tough ആണ് questions എടുക്കും. ഈ ടഫ് ആണ് questions ആണ് 600 above വരുന്നതെല്ലാം. അത് അറ്റൻഡ് ചെയ്യുമ്പോഴാണ് 600 above ഷൂട്ട് ആവുന്നത്. ഇല്ലെങ്കിൽ ഷൂട്ട് ആവാതെ. ഓക്കെ, അപ്പോൾ 600 above സ്കോർ ഇരുന്നാൽ യു ആർ അറ്റൻഡഡ് സം ഓഫ് ദ ടഫസ്റ്റ് ക്വസ്റ്റൻ. അങ്ങനെ ഇരുന്നാൽ ഫിസിക്സിൽ ഒരു 140 above മാർക്സ് എടുക്കും. 100% 140 above മാർക്സ് ഫിസിക്സിൽ വരാതെ 600 above ക്രോസ് ആവില്ല. ഈ 140 above 180യിൽ 140 above മാർക്ക് ചെയ്യണമെങ്കിൽ there are some difficult level questions will be there. There are 5 to 8 questions will be there in a core questions മാതിരി ഇരിക്കും. മറ്റപടി എല്ലാമേ ഒരു ആവറേജ് ലെവലിൽ പഠിക്കുന്ന സ്റ്റുഡൻസ് അറ്റൻഡ് ചെയ്യാം. സോ ഔട്ട് ഓഫ് ഒരു 37-38 വരേക്കും ഒരു ആവറേജ്. ഇപ്പോൾ ഒരു അപ്രോക്സിമേറ്റ് പറഞ്ഞാൽ ഒരു 15 ക്വസ്റ്റ്യൻ അല്ലെങ്കിൽ ഒരു 12 ക്വസ്റ്റ്യൻസ് ഈസി ആയിരിക്കും. 12 questions അറ്റൻഡ് பண்ணினா எவ்வளவு மார்க் எடுக்கும்? 12 into 4 48 marks. ஓகே, நார்மலி நீங்கள் உங்களை ஃப்ரெண்ட்ஸோ இல்லைங்க உங்களை ஒரு சர்க்கிள் இருக்குன்னு பார்த்தோன்னா ஃபிசிக்ஸில் ஒரு 70, 80, 85, 60 ആ ഒരു റേഞ്ചിൽ ആയിരിക്കും മാർക്ക്. എന്നാൽ സിമ്പിൾ ക്വസ്റ്റ്യൻ്റെ ആൻസർ ചെയ്യും. ലിറ്റിൽ എബോ ഐ മീൻ ആവറേജ് ക്വസ്റ്റ്യൻസിൻ്റെ ഒരു പാതിയല്ല ആൻസർ ചെയ്ത് ഇങ്ങനെ നിൽക്കും. അപ്പോൾ വരുമ്പോൾ വെരി സിമ്പിൾ ആൻസർ ചെയ്താൽ ഒരു 40-45 മാർക്സ് താ വരും. ആവറേജ് ക്വസ്റ്റ്യൻസ് കൂടെ ആൻസർ ചെയ്തതിനാൽ ആവറേജ് ക്വസ്റ്റ്യൻസിൻ്റെ ഒരു പാതി ആൻസർ ചെയ്തതിനാൽ എவ்வளோ വരും? You will come to around 80-90 ranges, not 100. You will never cross 100. Okay. ഇനി ആ ആവറേജ് ഫുൾ ആൻസർ ചെയ്തതിനാൽ if you are answering all the average question, your score will be between 100 and 110. 110ക്ക് higher no chance. Okay. Maximum 120 worst cases 120 അതാ. So there are some questions 60 marks next to 15 questions ഉണ്ട്. ആ 15 questions അതിൻ്റെ ഡിഫിക്കൽട്ടി ലെവൽ വേരിയിങ് ആയിരിക്കും. അതിൽ മോസ്റ്റ് ഡിഫിക്കൽട്ടായ അല്ലെങ്കിൽ മോസ്റ്റ് ട്രിക്കിനായിട്ടുള്ള ഒരു 7 questions അല്ലെങ്കിൽ ഒരു 8 questions ഉണ്ടാവും. ആ 8 questions once you are answering you are cracking anything എന്നാണ്. Okay, അത് ആൻസർ ചെയ്യുന്ന ഓൾ ഇന്ത്യ ലെവൽ ഇറ്റ്സ് എ വെരി ലെസ് നമ്പർ ഓഫ് സ്റ്റുഡൻസ് വിൽ ആൻസർ ദാറ്റ് ബിക്കോസ് ദ ക്വസ്റ്റ്യൻ ഈസ് ഫ്രെയിമിംഗ് ലൈക്ക് ദാറ്റ് ഓൺലി ബിക്കോസ് എവരിബഡി കനോട്ട് ആൻസർ. അതാണ് சொன்னது. If antimony is added, it is what type of semiconductor? It will never ask because everybody know. They know everybody will know. Okay, so they want to know what is difficult. I am very sure that till morning onwards, till we are saying this is the most difficult problem you have solved. Correct? You feel difficult, I also feel difficult. So the same thing, if you feel difficult, your friend also feel the same difficulty level. Difficult questions once you are learning, you are cracking the examination in a simple way. But difficult and solite never keep something away. If it is feel difficult, everybody it is difficult. If you feel it is simple, everybody it is simple. Okay, so there are certain kind of questions I'm saying like 7 to 8 questions will be there. These questions will be comes in that category. Very rare, only very rare students are answering. Such model questions is also there. First question, whatever I have given to you first is an average level question. At least a student who learned the theory in a conceptual way, at least he can give a try. But if he practiced with some questions also like this one, he can able to attend the first question. Second question answer little more practice is required. Third question answer little more. Okay, അതാണ് അതിൻ്റെ ആ ഒരു ഗ്രാഫ്. ഇപ്പോൾ ഫസ്റ്റ് ക്വസ്റ്റ്യൻ സിമ്പിൾ അല്ല, വെരി സിമ്പിൾ ബൈ കമ്പാരബിൾ ടു ദിസ്. സെക്കൻഡ് ക്വസ്റ്റ്യൻ ഒരു എക്സ്ട്രാ ഒരു കോൺട്രിബ്യൂഷൻ വന്നു. തേർഡ് ക്വസ്റ്റ്യൻ ആകുമ്പോൾ അത് അധികமாக വന്നു. അതേമാതിരി ആയിരിക്കും നീറ്റ് എക്സാമിൻ്റെ പേപ്പറും. ഒരു സിമ്പിൾ ഉണ്ടാവും, ഒരു ആവറേജസ് ഉണ്ടാവും, ഒരു എബോവ് ആവറേജ് ക്വസ്റ്റ്യൻസ് ഉണ്ടാവും. ഈ സെക്കൻഡ് ആൻഡ് തേർഡ് ഇപ്പോൾ ആൻസർ ചെയ്തില്ല സെക്കൻഡ് ആൻഡ് തേർഡ് ക്വസ്റ്റ്യൻസിന് സച്ച് മോഡൽ ക്വസ്റ്റ്യൻ നോട്ട് ഓൺലി ഫ്രം ദിസ് ചാപ്റ്റർ ഫ്രം എവറി ചാപ്റ്റർ ഇഫ് യു ഏബിൾ ടു ആൻസേഴ്സ് ദെൻ സ്കോർ വിൽ ഗോ എബോവ് 600 or above 550 ലൈക്ക് ദാറ്റ്. ഇല്ലെന്നാ അതൊക്കെ കീഴാം. all depends upon your work. Okay, so we'll go to the next topic. The next heading, PN junction diode. PN junction. Notes correct. Once you study notes, you can answer 99% questions from the notebook only. PN junction. 100 சொல்ல முடியாது கரெக்டா? PN junction. PN junction. Prida, what is PN junction? P type, N type. Okay, so what will happen then? P type, N type materials, correct? P type, N type materials when connected together, it is called a PN junction. What is happening inside when a P type material connected with an N type material? What is happening in between these two? Electrons will be moved from N to P and holes will be moved from P to P. Then what will happen? What is that? Depletion regions will be formed. Correct. Depletion region will be formed. Depletion region consists of what? What is there within depletion region? Electrons and holes which can able to move? No. Which means immobile. Immobile carriers are there. Okay. So we learn deeply. So right, PN junction diode. When a P-type material is connected with an N-type material, when a P-type material is connected with an N-type material, then it is called a PN junction. You will get one question from this section, sure. PN junction. It's all question in 2021. PN junction. When a P-type material is connected with then listen to the board carefully, then we will see. Okay, so you have a P-type material and one N-type material. N side will contains what is the majority carriers? Electrons. So I am putting as a dot sign to represent electrons. So more number of electrons. But what is the minority carriers? Two holes I am representing to represent minority carriers. So this is one. You can also maybe draw along with me so that we can say majority and this is minority carriers. Minority carriers. Majority carriers and minority carriers. Okay. P side majority holes. Minority carriers are carriers. Minority carrier. The electron holes. Minority carriers here holes, and this side electrons. Okay. This is a very simple theory. There is no complications. Nothing is there. It's straightforward. And next, listen to the board once you have drawn. Electrons holes in the bracket majority carriers electrons ആണ്, minority carriers holes ആണ്, ആ സൈഡിൽ നേരെ opposite. Okay. Okay. Next, what will happen? See, in chemistry also you have learned some term is called concentration. Correct? Sulfuric acid, concentrated lesson. Sulfuric acid, we can't use a very concentrated sulfuric acid for many purpose because it's very dangerous. So what we will do? We'll dilute it. Dilute means you can give some extra water or something else. So its concentration will be reduces. So concentration, every physical things which are moving from high concentration to lower concentrations. Why it is happening like this one? For example, all your home, if you're staying in homes, an apartment, wherever it is, so water tank will be there. Okay, water tank will be there. We are keeping water tank above the your house, on top of your house. Why you are not keeping on the down? Because you know water has to come with a force. You will say with a force. Correct? More height means more pressure will be there on the pipe when the water is coming. So what is happening will be there means if I am standing on the ground level, I am a very stable person. I am very stability. Okay, every object, every living and non-living being are intended to be in a stable position. If I am sleeping, that is my very comfortable stable position. If I am sitting, I am more comfortable. If I am standing, I am less comfortable. If you are traveling in a bus, immediately when entering to the bus, we will look for a seat. Why? Because I want to make myself in a stable position. Because when I am standing, I am not stable. I know I may fall down. Correct? Bus immediately we look for a seat. Train line, we immediately will look for a seat. But stability, everybody is looking for stability. Okay, very low risk, most stable positions. That is chemistry, physics, maths, biology. Everywhere we are looking for stability. So what will happen in these cases? In this case, it means here high concentration of holes, high concentration of electrons will be there. So more concentration means everybody in a crunched situations. Okay, everybody in a tight situation. If some room is given here for this electron, what will happen? These electrons will get relaxed. Everybody will be split. Okay, now this classroom is this much size. Average one bench, 4 students are sitting. If it is a bigger classroom, large number of benches will be there, means 3 of you, in a bench 3 people will sit. Others will sit back and back and back and back. Correct? Because more comfortable, little more relaxed. Okay, same way here this is the room space for initially for n type and this is the room space for p type. So whenever n got an extra room space will be here, what will happen? These electrons can move to p region and the holes can move to n region, because concentration of electrons is higher here, concentration of holes will be higher, will be here. What will happen? These holes will be tried to move towards n, these electrons will try to move towards n side. So these electrons will have what charge? Negative charge. These holes will have positive charge. Suppose I am assuming this electron is moving towards this hole and it will undergo what? Recombination. Why the word is called recombination? Repeat, recombination means what? Again combining. Initially these electrons comes from an hole. Now it is again going back to the hole. So it is reprocess. That's what it is called, recombination. It's combining again. Okay. So whenever this electron meet this hole, it will combine. Similarly, if this hole is moving, this will meet another electron and it will recombine. Once it is recombined, these electrons and holes cannot move because its energy is less, because it is stable. Now it is unstable. Once all of you will be in a tight room, a very tight number will be there, means everybody unstable. Everybody will be trying to move there and wherever comfortable they stand. So these electrons will move here and find a hole and sit in that hole and it's very comfortable. Then it will not move because it is stable. Similarly, these holes can move toward this side. So once these processes happen, this is called in chemistry also, physics also, this you call it as diffusion. Okay, it is diffusing from n to p and diffusing from p to n, and this is a diffusion process. This diffusion process give rise to what? Recombination of electrons and holes. Okay, electrons and holes are recombining. Recombining means it is moving shorter distance and then stopping there. If there is a movement, definitely there is a current for some time. Initially it is moving, then it is not moving. So whenever a p-type material is placed near with an n-type material, initially there is a movement of carrier. So for initially just for 1 second or 1 microsecond of time there is a current. After that if you come and look, there is no current. Okay, which means in a simple way I can say a p-type material and n-type material connected, immediately you connected an ammeter, you can see a current. But after 1 or 2 seconds that current will goes to 0, because it means what? Because there is no movement. Initially there is a movement, now there is no movement, everybody come to rest position, or I can say stable position. So whenever there is no movements are happening, after some time there is a region will be formed on the center, and that region is called the depletion region. That means in a p-type and n-type material combined, at the center there is a strip regions will be formed, and here these electrons will be there and electrons are accumulated here and holes are accumulated on this region. What will happen? These electrons are try to move here, these holes are try to move here. Next, after some time, what will happen means, this is another hole. This hole will, because here electronic concentrations will be very high, so very much push will be there, or pull will be there towards the center. So whenever this hole is trying to cross this region and coming to this region, it is not possible. Why? Because this hole will be getting repelled, because already a sequence of holes will be formed. And this region is called what? Depletion region. Depletion region. So depletion region consists of immobile, means no immobile holes and immobile electrons will be there. Now this area positive and this area negative. This will act as a battery. This will act as a battery. This area, because there is a voltage will be there, right? This is always a plus, this is always a minus. A small voltage will be there, 0.5 volt, 0.2 volt, might be voltage. That voltage is called contact potential, barrier potential. So contact potential is formed where the voltage depletion region is called contact potential, or it is also called barrier potential. It's also called barrier potential. Okay, two names, contact potential, barrier potential, or this is also one more word is called cut-in potential. Maybe at least some of them you have already heard. Contact potential, barrier potential, or cut-in potential, all same, in different book, different names. So there is a strip will be formed. Once we are looking, there is no movement. After some time, if you come and look, there is a strip of positive on the inside, strip of negative, battery at active. In battery, the positive will be there for a battery. Voltage. So this is like a positive negative combination. Battery potential difference, voltage in a difference. That difference is called contact potential, barrier potential, cut-in potentials. All are same, all are the same terms. Understood? So we'll write it as points. Called PN junctions. So the next point below, right? The first point. In the P side, hole concentration is higher. In the P side, hole concentration is higher. In the P side, hole concentration is higher. In the P side, hole concentration is higher and it moves towards N side. And it is moved towards N side. In bracket, right? Higher concentrations to lower concentration. Higher concentrations to lower concentration is moving from higher concentration to lower concentration. Higher concentration to lower concentration. Similarly, next point, similarly in N region, electron concentration is higher. Electron concentration is higher. So electrons moves from N to P. N to P. Electrons moves from N to P. After some time, a barrier region formed in the PN junction. A barrier region formed in the PN junction. Barrier region is formed in the P junction. This region is called depletion region. This region is called depletion region. This region is depletion region. Okay. The voltage at the depletion region is called barrier potential or cut-in potential or contact potential or contact potential. This is called barrier potential, cut-in potentials or contact potential. Next one, depletion region consists of immobile charge carriers, only immobile, it is not able to move. Depletion region consists of immobile charge carriers which is not contributing to current, which is not contributing to current, which is not contributing to current, current ku contribute illa, not contributing to current. Next one, graphical representation of variation of barrier potential. Graphical representation of variation of barrier potential. So where PN junction, junction point, the voltage will be higher at P side or N side? This is P side and this is N side, and N side what is will be there? Holes will be there, depletion region. Here what is will be there? Electrons will be there. Okay, so I am taking this region and extending will be here, and this is the center of the region, right? Graph. So here positive potential, here negative potential. So voltage will be higher at the positive side, and voltage here positive side voltage will be higher and it is going, and here it is going to where? The next one. So this is the center region, and this height is called a barrier potential VB. This is a voltage axis and this is V versus D graph. This is called barrier potential. This is positive, and so positive highest voltage, voltage coming out. Okay, and that height is called barrier potential, and the barrier potential for germanium standard value 0.3 volt. Depletion region width standard value 10 power minus 6 micrometer. Then electric field will be equal to V by length or V by D, correct? Electric field. So electric field for a silicon, this is for a silicon. So 0.5 divided by 10 power minus 6 micrometer. So how much will come? 0.5 into 10 power 6 micron we have to convert meter. So 10 power minus 6. So 0.5 into 10 power minus 12 volt per meter. Silicon value, germanium value, depletion regions the standard value. If it is not given in the question, suppose if you want to solve for that, you want the depletion region width, then you can take it as 10 power minus 6. Barrier potential for silicon 0.5, for germanium 0.3, and E is equal to electric field is equal to potential by length. For silicon 0.5, germanium 0.3 divided by micrometer meter lot convert 10 power minus 6 into 10 power minus 6, go to numerator 10 power 12. So 0.5 into 10 power 12 volt per meter. This is a small value or a higher value? Very higher value. So which means electric field strength at the depletion region is high. So below right, electric field strength at the depletion region is very high. Electric field strength at the depletion region is very high. Just the voltage and other graph, nothing else. There is a hike from here. That's all. Next one. Symbol of a diode. Just write a short note. Symbol of a diode. Of course, you know, right? Symbol of a diode is what? Many times drawn in. Many, right? Symbol of a diode. A line is small. Okay, no, this should be small. This is positive and this is negative for a diode. Why the diode symbol is like this? Why it is not something like any other symbol? What is the meaning of this one?
At center there is depletion region.
Okay.
In between the terminals.
So why this triangle sign? So instead of this one, why I am not drawing the diode symbol like this, for example? Just a thought. I'm asking. Anyway, I did not ask it.
Potential decrease.
Current direction. Diode is a unidirectional device because a diode will conduct a current in only one directions. Normally, if you want to mark directions, we'll put what? Arrow mark. Correct. So this is a kind of arrow mark because diode is a unidirectional device, means diode will not conduct this way. Diode will always conduct from positive to negative only. This line is what is that? This line is no meaning, nothing. There is no significance for that. And this is an extra arrow mark which is representing this is high, so this is low, to represent like high, low, positive, negative, no other meaning. But this triangle will have a meaning that is representing that is conducting in unidirectional. One direction current reverse. Which means if you have a resistance will be here. In current electricity you have learned current can go like this or current can go like this. This is possible for an inductor, for a resistor, but for a diode, current is always go like this one. Reverse is not possible. Okay, always the current will flow from positive to negative because diode is a unidirectional. So the important point will be that diode is a unidirectional device. Unidirectional device. That's a symbol in the meaning. Okay. Anyway, out of scope. Okay, symbol of diode. Next one. Characteristics of diode. Characteristics of diode. Characteristics of diode. So, the meaning is characteristics, behavior, nature. Correct? Characteristics means nature, behavior. Okay. Means everything will have its own character. I have my own character, you have your own character. So diode will have a character. How I can measure a character of a person, for a simple way. How I can measure a character of a person? If I am talking to him in 1 hour, if I am talking to him 2 hours, I cannot get his character, right? So how should I know the character? Over the run. Okay, over for maybe 1 year or 2 years only, I will know the character of a person. Or to know the character of a person, I have to give different situation, like lively difficult situation I have to face, I have to give, or a very happy moment I have to give, or a sad moment I have to give. Then I have to see how that person is reacting to each and every situations. Then I can say, okay, he's a very stable, he's a very cool guy. Okay, we'll say in a different definitions, right? Depends upon how he is behaving in a different conditions. Some people are very sensitive. If a minor things will say, he will get depressed. Okay, something will happen, he will over enjoyment. So there are different people will be there. So how we will measure, how we will see the character of a different person means we are giving different situations to him. ഒരു ഹാപ്പി മൊമെന്റ് കൊടുക്കും, ഒരു സാഡ് മൊമെന്റ്, ഒരു ഓവർ എക്സൈറ്റ്മെന്റ് മൊമെന്റ്സുകൾ, എക്സൈറ്റ്മെന്റ് ഇല്ലാത്ത മൊമെന്റ്സുകൾ. സോ വിൽ ഗീവ് ഡിഫറെന്റ് സിറ്റുവേഷൻസ് ക്രിയേറ്റ് ചെയ്തിട്ട് വിൽ എക്സ്പെരിമെന്റ് ദാറ്റ് കൈ. So this way we are understanding the character of a person. Similarly, the same principle is using while we are understanding the behavior of any electronic circuit. We are giving high voltage, we are giving high current. We'll see how that guy is behaving to us. So in your mobile phone, okay, of course you are using, now all of you are using fast charging. What is the meaning of fast charging? Only one meaning you know, it will charge very quickly. Okay, beyond that there are some meanings, right? We'll say 12 watt charger, we'll say 22 watt charger. Okay, once you taken to your charger, there are some small things written, right? Many things we can learn, we can read only with the help of microscope. Things are written will be there, right? There they have written voltage, there they have written watt, how much power it is using, watt they have written, voltage they have written, current they have written. Okay, suppose my phone is using 2.1 ampere current, for example. That is the current value given by the company. Then I am supposed to use 2.1 ampere charger to that wire. Okay, if I am using 2.7, what will happen? It will charge. It will charge. It will charge. That's why you have your charger on your home, but you are using everybody's charger on your home, right? Correct. Correct. Wherever free, we will just plug it. That's all. But our phone will have certain specification. Adukku voltage, adukku current, adukku power. So we are supposed to use a charger. That is the only charger we are supposed to use. But what we'll do, we'll use all the chargers. What will happen finally? Battery life will go down. That is the consequences. Okay, because we are not take care of our devices. Whatever will be there, we'll just plug it and use it. So everything will have its own specifications, and a specification out of that you are using. Suppose I am saying 2.1 ampere is the capacity you have to charge your phone. If you connect a 4 ampere charger, so 2.11 ampere, company is saying like, okay, you have taken one phone and 2.1 and the charger is given, and you charge 30 minutes, they will full charge. This is what company is giving. So definitely in 30-35 minutes it will full charge. But if you replace with 4.1 ampere another one, what will happen? Of course it will also charge us. It will also charge us, but it will charge us within 15 minutes. Within 15 minutes it will be full charge. You are very happy, right? Yeah, it will be full charge. So, but the device is really struggling to it. What is the device is struggling? There are internal components will be there within a phone. Your IC chip, electronic circuits, many things will be get overheated. But your phone still will work perfectly fine, because the device is adjusting many things for its surveillance. Because the device want to stay, okay, it has to still work very perfectly, so device will do certain adjustment. So there are certain regulatory measures are there inside. So device will adjust one time, device will adjust it 2 times, device will adjust thousands of times for your betterness. Finally it will dead. Okay, this is what is happening, yeah, in reality. So how we will measure the character? Suppose I brought one 15,000 phone, I brought another 20,000 phone, same experiment I am doing on both phones simultaneously. Maybe one phone will go after 6 months, another phone will go after 8 months. Then I will say 8 months is good. Correct. I'll say 8 months. Because why? Because durability will be very high, because I can use it for a long time. But durability and performance is a measure. But you are exposed into a different environmental condition. Low voltage, high voltage, high power, low, but still it is struggling to save you. Correct. So many situations are happening, but the device is still stable. The device is behaving in a different way. That is what is also called a diode. Diode will also behave, but diode will also have a certain character. Beyond that, if you are giving something also, diode will adjust for a certain period of time. Over the aging will happen, then it will be get dead. So similar way, characteristics means the behavior of a diode for a different ranges of voltage, for a different ranges of current. Once you are giving a different voltage, what will happen to the diode? If you are giving less current, what will happen? If you are connected in opposite way, what will happen? All these things we are going to analyze. That's what in school also you have learned 2 things, forward and reverse bias characteristics of what is called biasing. Biasing in physics, it is called voltage. No other meaning. There are a lot of meaning for biasing, right? So biasing in physics, it's simply called voltage. So forward bias means forward voltage. Reverse bias means reverse voltage. So characteristics we are going to learn in two contexts: forward characteristics, reverse characteristics. Forward characteristics, one way I am connecting the diode. In reverse characteristics, I am connecting the diode in another way. Then I will see how it is behaving. This is what we are going to do, characteristics. So write the first heading, characteristics of a diode. And subheading very first one, forward characteristics. Forward characteristics. Break time ani lunch eppuda 1 o'clock. Okay. You feel hungry? No. Forward characteristics. I have some target to finish today. Let's see. Forward bias or forward characteristics, you can say. We'll write one diagram, then I will leave you for next break. Okay, so forward bias. What is called forward bias? Diagram. This is simple. Again, this is very simple. There is no complications. Positive is connected with the positive terminal of the battery. Negative is connected with the negative terminal of the battery. Then such type of connections is called forward biasing. Okay, such type of connection is called forward bias. Okay, P type is connected with the positive terminal of the battery, N type is connected with the negative terminal of the battery. Appa idhe mari connections irundha, we call it as forward biasing. P type is connected with the positive terminal, N type is connected with the negative terminal of the battery. Then below write P type connected with the positive terminal, N type connected with the negative terminal of the battery. Then it is called forward bias. Additional things I am drawing here. In forward bias, depletion region width is less. In forward bias, depletion region width is less. Depletion region width is less. Why it is less? Why the depletion region width is less? See here, positive. Here what is contains will be here. Here holes will be here. Here battery, negative. Here what is contains? Electron. So this negative and this electrons will repel. So all the electrons here are trying to move towards this side, and the holes P positive with the holes will repel. So all the holes will try to move towards this side. So both the side there is a force. Okay, left and the right and the left force are depletion region crunch. It become tight. So the depletion region width will be very less in case of a forward bias. Okay, but there is a voltage will be there. That voltage is called what? Barrier voltage. So below, right, barrier voltage still exists. Barrier voltage still exists. Barrier voltage still exists. Okay, barrier voltage still exists. Okay, so this I am giving as capital V. Okay, if V greater than VB, if V greater than VB, barrier voltage 0.5 or 0.6 or 0.7, different metal, different. So if I am giving a higher voltage than barrier potential, what will happen? Barrier means obstacle. Okay, something is preventing me. If I am giving a voltage which is higher than the obstacle, what I can do? I can overcome the obstacle. This is a barrier. I have to give extra voltage. If I am giving a high voltage, what will happen? Now see, these holes cannot move to this side because of there is a blocking here. These electrons cannot move to here because there is a blocking here. So in order to block, if I am giving extra energy here, what will happen? This can cross the barrier. This can overcome the barrier. Who can give the energy? Only the battery can give the energy. Electrical energy can give. So if I am giving a voltage which is greater than barrier voltage, what will happen? IF will start. What is IF? IF is called forward current. IF is called forward current. So below write, when if V is greater than VF, IF will start. IF is called forward current. IF is called forward current. So when the external voltage is greater than barrier voltage, the forward current will start to conduct. Okay, if forward current will be there, definitely there is a forward resistance, forward things, other stuff will be there, that we'll see after now. So understood, huh? Whenever the voltage will be greater than the forward the voltage will be greater than this one, then there is a current. So what will happen if the voltage is less than VB? So we'll write that point, then we'll wind up. If V is less than VB, what is the value of IF? IF equal to 0. There is no current, because it cannot overcome the barrier. It cannot overcome the barrier. Okay. Next, forward bias characteristic. Forward bias characteristics. Forward bias characteristics. It is the plot between. It is the plot between. It is the plot between. Forward bias characteristics. It is a plot between forward current and applied voltage. It is the plot between forward current and applied voltage. Voltage versus IF. Okay. So forward current versus applied voltages. Okay, VB is a barrier voltage. This is not barrier voltage, this is applied voltages. Next, what will happen, sir? See, I know barrier voltage, for example, is equal to 0.7. This is a standard value of barrier voltage. 0.5, 0.6 എല്ലാം വരും. Okay, material to material. But ഈ 0.7, if for example 0.7 ആയിരുന്നാ ഇതിന്റെ P type materials in the central voltage ആണ് എவ்வளോ വരുന്നത്? ഈ 0.7 എന്ന് പറയുന്നത് 0.7 ഓ 0.6 ഓ ഇപ്പോൾ ബാരിയർ വോൾട്ടേജ് എടുത്തിട്ടാണ്. ഇപ്പോൾ 0.5 ഇതല്ല സിലിക്കൻ്റെ വാല്യൂ 0.5. ഇപ്പോൾ ഈ 0.5 ആണ് ഇത് കിടക്കുള്ള വോൾട്ടേജ്. ഈ വോൾട്ടേജ് കൂടെ അധികമായി കൊടുക്കണം. ഇപ്പോൾ സപ്പോസ് ഐ എം കണക്ടിങ് വൺ ബാറ്ററി ഹിയർ. Suppose I connected one battery here. So this is a P-type material, this is an N-type material. I connected one battery here, both positive and negative. And here I am giving 0.1 volt. 0.1 voltage means battery. Battery is an energy source, right? This 1 volt corresponding energy. How to find out energy for voltage? W is equal to QV, electrostatics video. W is equal to QV. So Q means what? 1.6 into 10 power of minus 19 coulomb into E voltage 0.1. This is the energy given by whom? Battery. This energy given by the battery. Okay, so I am giving this much energy. Now I am looking what is the energy will be here. What is the energy will be here? Here also W is equal to QV. Q is the electronic charge. 1.6 into 10 power of minus 19 into voltage. Voltage means what? 0.5. Electron volt alla volt. Voltage alla. So this much is the energy. So this energy is higher or this energy is higher? Which energy is higher? This energy is higher. This energy is opposing the flow of charge carriers. That's what it is called barrier voltage. Barrier voltage or cut-in voltage or contact potential. This voltage is actually opposing the flow of charge carriers because this barrier will have this much energy. Somebody is pulling me or somebody is pushing me. If I have a good strength, I can stay against him. I am keep on pushing with this energy, but this energy is very less. This is just 0.1. This is just 0.5. So this is higher. So here a higher blocking force will be here. Higher blocker will be there. But I am giving very less amount of energy. Because of the less amount of energy, holes will be here and electrons will be there. This electron cannot move and these holes cannot move. Why? Because I am giving less energy. Here high energy will be there. So in order to happen the movement of holes, because here positive, e positive ripple. So these holes can move like this. ഈ നെഗറ്റീവും ഈ ഇലക്ട്രോൺസ് ക്യാൻ റിപ്പൽ. സോ ദിസ് ഇലക്ട്രോൺസ് ക്യാൻ മൂവ് ടു ദ അതർ സൈഡ്. സോ ഇലക്ട്രോൺ ഹാസ് ടു ക്രോസ് ദിസ് ജംഗ്ഷൻ. ഹോൾ ആൾസോ നീഡ്സ് ടു ക്രോസ് ദിസ് ജംഗ്ഷൻ. ഈ ഒരു ജംഗ്ഷനിൽ ദർ ഇസ് എ എനർജി ലെവൽ, എ വോൾട്ടേജ് ലെവൽ. So what should I have to give? I have to give a more energy. To give more energy, what I have to do? I have to connect with another battery. ആ ബാറ്ററിയുടെ ലെവൽ എவ்வளோ ഇരിക്കണം? How much is the energy? 0.5 മിനിമം ഇരിക്കണം. ഇല്ല 0.5 കൂടെ അധികமாக ഇരിക്കണം. ഫോർ എക്സാമ്പിൾ ഐ എം ടേക്കിംഗ് 0.7 എടുത്തു. 0.7. ഇപ്പോൾ 0.7 കൊടുത്തിനാ now what is the energy? W equal to QV 1.6 into 10 power minus 19 into 0.7. അത് കൊടുത്തിനാ ഇവിടെ കൊടുക്കുന്ന എനർജി അധികം, ഇതിന്റെ എനർജി കമ്മി. ഈ ഇലക്ട്രോൺസ്ക്ക് ഹൈ എനർജി കിടച്ചു, ബട്ട് ഇങ്ങനെ ഇരിക്കുന്ന എനർജി കമ്മി ഇതാ. സോ ഇതിക്ക് മേലെ ജമ്പ് ആയി ദിസ് ക്യാൻ ഗോ. സോ വാട്ട് വിൽ സ്റ്റാർട്ടഡ് ടു ഫ്ലോ? Current will start to flow because electron can move and holes can also move. അപ്പോൾ ഇലക്ട്രോൺസും ഹോൾസും മൂവ് ആവണതൊക്കെ ഈ ബാരിയറിൽ ഇരിക്കണ ഈ വോൾട്ടേജുക്കും ഒരു മേലെ അധികമായ വോൾട്ടേജ്, ഹയർ വോൾട്ടേജ് ഐ ഹാവ് ടു ഗീവ് ദാൻ ദി ബാരിയർ വോൾട്ടേജ്. ദെൻ ദി ഇലക്ട്രോൺ ആൻഡ് ദി ഹോൾസ് ടുഗദർ വി കോൾ ഇറ്റ് ആസ് charge carriers. The charge carriers can move across the junction. Then what will happen? IF will start. IF means what? Forward current will start. Understood? Forward. So we will write. So this is a voltage I am giving. I have different value. Here it is 0 volt. Here it is 0.1. Here it is 0.3. Here it is 0.5. Here it is 0.7, like this. And it is going and maybe up to 1 volt I am marking. So whenever I am giving 0 voltage, what is the energy when I am giving 0 voltage? What is the energy? 0. So energy is 0, no current. Whenever I am giving 0.1, what is the current? No current. Whenever I am giving 0.3, it can move? No. Whenever I am giving 0.5, it is just starting, right? Just starting. Okay. So whenever I am giving 0.7, what will happen? Current will start. So current will start from here like this. Current will start from here. So at this point, this line is break. So this voltage is called what? This voltage is called Neet voltage. This voltage is called Neet voltage. This is also called it as cut-in voltage. We can also call this as cut-in voltage. Okay, cut-in voltage. So simply it's called Neet voltage. So Neet voltage is the voltage which is we are giving above than which voltage? Barrier voltage. Barrier voltage നേക്കാളും അധികം വോൾട്ടേജ് കൊടുത്താലാണ് ഡയോഡ് കൂടെ കറണ്ട് പോകുന്നത്. Simple ആയിട്ടുള്ള. So this voltage is called Neet voltage or it's also called cut-in voltage. Neet voltage standard in some textbookil ഉണ്ട്, but Neet voltage remember as per NCERT. Okay, so I am giving a voltage which is greater than Neet voltage. Now you see, graph is not a straight line. Graph is a slight bending like this one. Okay, but you also have learned some graph like this one. For example, voltage versus current graph in current electricity. Voltage when voltage is 2, graph is what? This graph is purely a straight line. This is what? This is not a straight line. Initially no current. Currents are starting. Again the shape is not a straight line. It is some bending will be there. There's no bending. This is a standard graph. So from Ohm's law, Ohm's current electricity, you are writing proportional to I small class 8th standard. Correct? R proportional. V is proportional to voltage 1, voltage 2, current 2. Means what voltage? Why this is not happening here? The reason is this is called non-ohmic conductor. This is called non-ohmic conductor because semiconductor devices are not obeying Ohm's law. Only conductors, that's Ohm's law definition, at constant temperature. You remember 5 years, 6 years back, at constant temperature for a conductor, voltage is directly proportional to current. Why they say at constant temperature? When temperature increases, what will happen? Correct. Conductivity will be changes, right? When resistance increases, when temperature increases, resistance increases, conductivity. അതാണ് ഓംസ് ലോന്റെ ഫസ്റ്റ് അറ്റ് കോൺസ്റ്റന്റ് ടെമ്പറേച്ചർ. 8th സ്റ്റാൻഡേർഡിൽ தெரியாது. അന്ന് അതേപോലെ ഡെഫിനിഷൻ പഠിക്കുക, അതേമാതിരി ഇതിന് 3 മാർക്ക്. ഹാപ്പി കേട്ടോ. അറ്റ് കോൺസ്റ്റന്റ് ടെമ്പർ, അതാണ് ആ മീനിങ്. അത് ടെമ്പറേച്ചർ ചേഞ്ച് ആവും, റെസിസ്റ്റൻസ് ചേഞ്ച് ആവും. അതുകൊണ്ടാണ് ഡെഫിനിഷൻ വരുന്നത് അറ്റ് കോൺസ്റ്റന്റ് ടെമ്പറേച്ചർ ഇൻ എ കണ്ടക്ടർ വോൾട്ടേജ് ഇസ് പ്രൊപ്പോർഷണൽ ടു കറന്റ്. സോ ഇറ്റ് ഈസ് ഫോർ എ കണ്ടക്ടർ അറ്റ് കോൺസ്റ്റന്റ് ടെമ്പറേച്ചർ. ദിസ് ഈസ് നോട്ട് ഒബേയിങ് ഓംസ് ലോ, സോ ദിസ് ഈസ് കോൾഡ് നോൺ ഓമിക് കണ്ടക്ടർ. ഡയോഡ് ഈസ് എ നോൺ ഓമിക് കണ്ടക്ടർ. എയിംസിന് ജനറൽ കോമൺ ആയിട്ട് കേൾക്കുന്ന ഒരു വിച്ച് ഓഫ് ദ ഫോളോയിങ് സ്റ്റേറ്റ്മെന്റ് ഈസ് ട്രൂ. മൾട്ടിപ്പിൾ ആൻസർ ക്വസ്റ്റ്യൻസ് ഇരിക്കുங்களா, മീൻ 2 years or 3 years ബാക്ക് അതേമാതിരി ക്വസ്റ്റ്യൻസ് இருக்கும். മൾട്ടിപ്പിൾ ആൻസേഴ്സ് വരും. അത് ABCD 4 ഓപ്ഷൻ കൊടുക്കും, അതിൽ 2 ഓപ്ഷൻസ് കറക്റ്റ് ആയിരിക്കും. എന്നിട്ട് ആ 2 ഓപ്ഷൻസ് ഏതാണെന്ന് വേറെ 4 ഓപ്ഷൻസിൽ കേൾക്കും. പുരിക്കില്ല. അത് 4 സ്റ്റേറ്റ്മെന്റ് കൊടുക്കും. 4 സ്റ്റേറ്റ്മെന്റ് കൊടുത്തിട്ട് വിച്ച് ഓഫ് ദ ഫോളോയിങ് സ്റ്റേറ്റ്മെന്റ്സ് ആർ ട്രൂ, ABCD 4 സ്റ്റേറ്റ്മെന്റ് കൊടുക്കും. എന്നിട്ട് ഫസ്റ്റ് ഓപ്ഷൻ എടുക്കും. ഫസ്റ്റ് ഓപ്ഷൻ A and B കറക്റ്റ്. ഇതേമാതിരി ഇരിക്കും. B and D is correct like this. മൾട്ടിപ്പിൾ ആൻസേഴ്സ് ക്വസ്റ്റ്യൻസിൽ നിറയെ സ്റ്റേറ്റ്മെന്റ്സ് ഉണ്ടാവും. അതിൽ ഒരു സ്റ്റേറ്റ്മെന്റ് ആയിരിക്കും ഡയോഡ് ഈസ് നോട്ട് ഒബേയിങ് ഓംസ് ലോ, ഇറ്റ് ഈസ് എ നോൺ ഓമിക് കണ്ടക്ടർ. 2 റീസൺ. ഒന്ന് നോൺ ഓമിക് കണ്ടക്ടർ ആദ്യ റീസൺ, ഇറ്റ് ഈസ് നോട്ട് എ കണ്ടക്ടർ, ഇറ്റ്സ് എ സെമി കണ്ടക്ടർ. സെക്കൻഡ് വൺ, ടെമ്പറേച്ചർ കോഎഫിഷ്യന്റ് ഈസ് നെഗറ്റീവ്. ഫോർ കണ്ടക്ടർ ഇറ്റ് ഈസ് പോസിറ്റീവ്. എല്ലാം ഓപ്പോസിറ്റ് ആണ്. അണ്ടർസ്റ്റുഡ്? സോ ഡ്രോ ദിസ് ഗ്രാഫ്, then we'll write. ഇത് മട്ടും ജസ്റ്റ് ഗ്രാഫ് ഈസ് ഇനഫ്, then we will write it.
அந்த கிராஃப்ல 0.5 இன்க்ரீஸ் ஆகಲಿ, அதுக்கப்புறம் இன்க்ரீஸ் ஆகும்.
0.5 ബാരിയർ വോൾട്ടേജ് എടുത്തണം. ബാരിയർ വോൾട്ടേജ് എടുത്തനാൽ ട്രാൻസിസ്റ്റർ ബാരിയറിനെ ഓവർകം ചെയ്യണം. അപ്പോൾ ബാരിയർ 0.5 ആണ്. അപ്പോൾ 0.5 കൂടെ നെക്സ്റ്റ് കൊടുക്കണം. നെക്സ്റ്റ് ലെവൽ എന്ന് പറഞ്ഞാൽ അപ്പോൾ 0.6 ആകുമ്പോൾ ഇങ്ങനെ സ്റ്റാർട്ട് ആവണ്ട, കുറച്ച് സ്റ്റാർട്ട്. പക്ഷെ ആ ഒരു വിസിബിൾ കറണ്ട് നമുക്ക് കാണിക്കുന്നത് 0.7 ആകുമ്പോൾ ഒരു 0.1 ആംപിയർ അന്ത മാതിരി ഒരു മെഷറബിൾ വാല്യൂ വരും. ദിസ് യു ആർ ഡൂയിങ് ഇൻ സ്കൂൾ ലാബ് റൈറ്റ്? ഗ്രാഫ് somehow you will make it correct. കറക്റ്റ് ഇതേ ഷേപ്പിൽ കൊണ്ടുവരും. അറ്റ്ലീസ്റ്റ് എவ்வளோ വാല്യൂ കിടച്ചാലും അഡ്ജസ്റ്റ് பண்ணி ഫൈനലി ആ ഗ്രാഫ് വരും. ബട്ട് ആക്ച്വലി ആ ഗ്രാഫ് വരാതെ ബിക്കോസ് യു ആർ നോട്ട് ഡൂയിങ് എക്സ്പെരിമെന്റ് അറ്റ് കോൺസ്റ്റന്റ് ടെമ്പറേച്ചർ. ആ ഡിഫറൻസ്. സർക്യൂട്ടിൽ കണക്ട് ചെയ്യുമ്പോൾ അതിൻ്റെ ഈ ഡയോഡ്സിൻ്റെ പ്രോപ്പർട്ടി എന്ന് വെച്ചാൽ പെട്ടെന്ന് ടെമ്പറേച്ചർ ഇൻക്രീസ് ആവും. ഫോണല്ല അതേമാതിരി തന്നെ ചാർജിന് വെച്ചാൽ പെട്ടെന്ന് ഫോൺ ഹീറ്റ് ആയിട്ടും. ഓക്കെ, ക്യാമറ ആണെങ്കിൽ എല്ലാം അതേപോലെ പെട്ടെന്ന് ഇറ്റ് വിൽ ബി ഹീറ്റിംഗ് വെരി ഫാസ്റ്റ്. അതുകൊണ്ട് തന്നെ ഹീറ്റ് ചെയ്യുമ്പോൾ അതിൻ്റെ ബിഹേവിയർ ഇങ്ങനെ ചേഞ്ച് ആവും. അതുകൊണ്ട് ഒരിക്കലും യു വിൽ നെവർ ഗെറ്റ് എ പെർഫെക്റ്റ് ഗ്രാഫ്. പക്ഷേ പെർഫെക്റ്റ് ഗ്രാഫ് ഇരുന്നത് ടീച്ചർ അക്സെപ്റ്റ് പണ്ണത്, യു വിൽ മേക്ക് ഇറ്റ് ആസ് പെർഫെക്റ്റ്. ബട്ട് യു വിൽ നെവർ ഗെറ്റ് അക്സെപ്റ്റ് ഗ്രാഫ്. വാട്ട് എവർ യു ആർ ഗെറ്റിംഗ് ഇസ് കറക്റ്റ് ഓൺലി. ഓക്കെ, ബട്ട് ഓക്കെ. Okay, so you have drawn this graph, I hope. Non-ohmic conductor in the IF versus V. E voltage in a knee voltage or cut-in voltage. In below, write point by point. Okay, so below write. When the external voltage crosses the barrier voltage. When the external voltage crosses the barrier voltage, current starts to flow. Current starts to flow. The voltage at which current starts to flow, the voltage at which starts to the voltage at which current starts to flow is called knee voltage or cut-in voltage. Board illada knee voltage or cut-in voltage. Okay, next one. Forward resistance of the diode. Forward resistance of the diode. Forward resistance of the diode. Diode is forward resistance. Forward resistance of the diode. RF. Forward resistance of the diode equal to delta VF divided by delta IF. I'll tell you what it is. Delta VF. divided by delta IF. Okay. Okay, what is this indicate is that I have a diode. Okay, I am giving a voltage will be here. Okay, suppose the question is saying the knee voltage of the diode. Knee voltage means the knee voltage of the diode is 0.7 volt. They will give it like the question, and you are giving 1 volt will be here. You know this voltage is higher than knee voltage. What will happen? Current will starts to flow. So that current is called the forward current. Currents are starting from 0 and going to some other value. So delta VF means the voltage which you are giving here, V minus what is called VK, knee voltage, V minus VK. V is the voltage in which you are giving here, and VK is the knee voltage. The difference between these two voltages is called forward voltage, divided by the delta IF. Why it is called delta IF means current is always starting from 0 to higher value. So higher value minus 0 is nothing but higher value. So we can say is equal to IF. This is called forward diode. Forward resistance. I mean forward bias ലാകുമ്പോൾ അതിന്റെ റെസിസ്റ്റൻസ്, അതാണ് അതിന്റെ മീനിങ്. ഫോർവേഡ് റെസിസ്റ്റൻസ് ഓഫ് ദി ഡയോഡ്. ഡയോഡ് ഫോർവേഡ് ബയാസ് ലാകുമ്പോൾ അതിന്റെ റെസിസ്റ്റൻസ്, ദാറ്റ് ഈസ് കോൾഡ് ഫോർവേഡ് റെസിസ്റ്റൻസ്. ഇനി റിവേഴ്സ് ബയാസ് വരുമ്പോൾ റിവേഴ്സ് റെസിസ്റ്റൻസും ചൊല്ലും. ഓക്കെ, ഇനി ഈ കേസസിൽ വി നോ പി ടൈപ്പ് ഈസ് കണക്റ്റഡ് വിത്ത് പോസിറ്റീവ് ടെർമിനൽ ഓഫ് ദ ബാറ്ററി, എൻ ടൈപ്പ് ഈസ് കണക്റ്റഡ് വിത്ത് നെഗറ്റീവ് ടെർമിനൽ ഓഫ് ദ ബാറ്ററി. ഓക്കെ, അപ്പോൾ പി ടൈപ്പ് പോസിറ്റീവും എൻ ടൈപ്പ് നെഗറ്റീവും. Holes are diffusing from P to N. Electrons are diffusing from N to P. Why? Because highest concentration on both sides. So here there are two types of current will be there. In current electricity you are learning drift current. Correct? Drift current is the current due to battery, due to external voltage. Diffusion current is due to the concentration difference. Concentration difference വരുമ്പോൾ highest concentration lowest concentration electrons പോകും, അതേമാതിരി ഹോൾസും പോകും. So in forward bias, in forward bias, I diffusion current, I diffusion is greater than I drift. Diffusion current ആയിരിക്കും അധികം, drift current ഉണ്ടായിരിക്കും, but diffusion current is higher in forward bias. Okay, so is there a point? The next point. In an ideal diode, resistance of the diode, in an ideal diode the question kandina, resistance of the diode is equal to 0 ohm. There is no resistance. With ideal diode is not giving any resistance. Diode will act as a normal conductor only. Okay. Next below, right? For a non-ideal diode, okay, knee voltage for silicon is equal to 0.7 volt. For germanium it is 0.3 volt. This is for non-ideal diode. For a non-ideal diode. Okay. So let's write one question. Just write one question. Find the current. Find the current I flowing through. Find the current I flowing through 1 ohm resistor. Diode is silicon and non-ideal. Diode is silicon and non-ideal. Diode is silicon and non-ideal. Draw the diagram also. Diode is non-ideal and silicon. How to find out the current? How to find out the current? Here voltage will be there. Simple ആണ് ഈ സർക്യൂട്ടിന് KCL ഉം KVL ഒന്നും വേണ്ടത്. Straight forward. Okay. നിങ്ങൾ പഠിക്കുന്ന നോഡൽ അനാലിസിസ് ഒന്നുമേ വേണ്ടത്. It's quite simple. 1 volt here. Silicon is how much? Knee voltage of silicon 0.7. അപ്പോൾ അതിന്റെ മീനിങ് എന്താണെന്ന് കേട്ടിനാ 0.7 voltage നോൺ ഐഡിയൽ ഉള്ള പ്രാക്ടിക്കൽ ഡയോഡ്സ് ആണ്. നിങ്ങൾക്ക് എவ்வளோ വോൾട്ടേജ് കൊടുത്താലും 0.7 വോൾട്ടേജ് അത് എടുക്കും. അതാണ് അതിൻ്റെ ഒരു പ്രോപ്പർട്ടി. അപ്പോൾ 0.7 വോൾട്ടേജ് അത് എടുത്തിനാ ബാലൻസ് എவ்வளோ വോൾട്ടേജ് ഇരിക്കും? 1 മൈനസ് 0.3 ഇരിക്കും. അപ്പോൾ ഇങ്ങനെ 1 വോൾട്ട് കൊടുക്കണം. ഈ ഡയോഡ് വന്നിട്ട് എவ்வளோ വോൾട്ടേജ് എടുക്കും? 0.7. അപ്പോൾ ഈ ഇതിന്റെ മീനിങ് എന്താണെന്ന് കേട്ടിനാ ലിസൺ ടു ദ സർക്യൂട്ട് വെരി കെയർഫുള്ളി. ഹിയർ വോൾട്ട് ആണ്. ഈ പോസിറ്റീവ് ലെഗ് 1 വോൾട്ട്. How much voltage will be here? I'll come here. Here 1 volt എന്നാണ് അതിന്റെ മീനിങ് ആണ് കേട്ടാ. ഇത് 1 ഇത് 0. Okay. So 1 minus 0 എന്ന് എടുത്താൽ എവിടെ എത്തും? 1. ഇനിയിപ്പോ ഈ ഒരു പോയിന്റ് എടുത്തു. ഈ പോയിന്റ് ടു ഈ പോയിന്റ്. ഇതിന്റെ വോൾട്ടേജ് എவ்வளோ? ഈ രണ്ട് ലെഗുകൾ ഇതിന്റെ വോൾട്ടേജ്. ഡയോഡിന്റെ നീ വോൾട്ടേജ് 0.7 വോൾട്ടേജ്. ഇനി ഈ പോയിന്റ് ടു ഈ പോയിന്റോട്ട് എടുക്കുന്നു. ഈ പോയിന്റ് ചൊല്ലുമ്പോൾ ഇതേ കണക്റ്റഡ് പോയിന്റ് ആണ്. ഇത് 0 വോൾട്ട്. ഈ ഒരു വോൾട്ടേജ് എவ்வளோ? അതായത് 0.7 അല്ല, ബിറ്റ്വീൻ ദീസ് ടു ആണ് 0.7. അതായത് ഇവിടുന്ന് 1 വോൾട്ട്, ആ 1 വോൾട്ട് നിന്ന് ഇത് എவ்வளோ എടുത്തു? 0.7 is taken by the diode. So how much will be here? 0.3. Okay, simple ആയിട്ട് യൂസ് ചെയ്യുന്ന അതേപോലെ. So 0.3 ഡയോഡ് എടുത്തു. So what is current? Current equal to voltage by resistance. What is the voltage between these 2 points? 0.3 minus 0. So 0.3. Resistance is how much? 1 ohm. So answer is 0.3 ampere. Understood? 1 കൊടുക്കും 0.7 തരും. 0.3. Okay. നോൺ ഐഡിയൽ ചൊല്ലിനാൽ അതിന് 0.7 ആണ് സബ്ട്രാക്ട് ചെയ്യാം. സിമ്പിൾ വേ. എന്നിട്ട് ബാലൻസ് വോൾട്ടേജ് എவ்வளோ ഇരിക്കും பார்க்க. അപ്പോൾ 1 കൊടുത്തു 0.7 എടുത്തു, ബാക്കി 0.3. 0.3 ഡിവൈഡഡ് ബൈ റെസിസ്റ്റൻസ് ഇസ് ഈക്വൽ ടു 1 ഓം. ഇനി അനദർ മെത്തേഡ് നിങ്ങൾ ആൻസർ ചെയ്യുന്നതാണ്. അനദർ മെത്തേഡ് ഇപ്പോൾ സംടൈംസ് ഇൻ കറണ്ട് ഇലക്ട്രിസിറ്റി യു മേ ഹാവ് ലേൺ ലൈക്ക് ദിസ് വൺ. ഇപ്പോൾ KCL വെച്ചിട്ട് ഐ വിൽ ഡ്രോ ലൈക്ക് ദിസ്. സോ ദിസ് ഈസ് 1 വോൾട്ട്, this is 0.7 volt, this is 1 ohm. I want to find out the current through the circuit. This already you know, right? So how to find out? Positive, I mean we'll apply KVL for example in a simple way. You can solve the circuit. Okay, if I am a guy, I am walking from here and I am going here and coming back. If I am going here, first I am seeing what? I am seeing the voltage. So plus to minus, decreasing means minus 0.7. Then this what is the voltage will be here? Plus to minus. I am going from plus to minus. So minus IR current into resistance. Then I am coming here. Then I am coming from here means I am going from where to where now? Minus to plus. So it is plus 1 is equal to 0. 1 minus 0.7 means 0.3 minus IR. Okay, so I equal to 0.3 divided by R. So 0.3 divided by 1. You know how to solve the circuit, right? Already you know. Okay, I hope you know. Okay. So the next heading, reverse bias characteristics. Reverse bias characteristics. Reverse bias characteristics. Reverse bias characteristics. So what is the reverse bias characteristics? This is a diode symbol I am representing. So this positive terminal is connected with negative terminal of the battery, and negative is connected with positive terminal of the battery. That connection is called reverse bias. Bias means voltage. So this is a voltage. Next, now any currents are flowing through the circuits? No current. Why no current is not flowing? Opposite directions. Okay. So in a real lattice structure, how it is happening? We have a p-type material, we have an n-type material. P is connected with the negative and n is connected with positive terminal of the battery. Here what is available? Holes are available. Here what is available? Electrons are available. So these holes are moving towards negative terminal and these electrons are moving towards positive terminal of the battery. So what will happen to the depletion region? Now both sides it is pulling on both sides. So what will happen? The depletion region width in this region, the width of the depletion region increases. Why it is increasing? Depletion region width increases. Why it is increases? Because of the holes is pulling towards negative terminal and electrons is pulling towards positive terminal. If this is continuing, if this width is increases and it will keep on increases, or after increasing it will stop. രണ്ട് option. First one, keep on increases. Second one, it is increases for some time, then it will stop. Increases for some time. For example, I am giving 1 volt. Then can you tell me what will happen? It will increase and stop. Okay. Then if I am giving 5 volt, what will happen? It will increases much more than 1 volt and it will stop. It will never stop. Okay, so if you are it will never stop in the sense, if you are increasing the reverse voltage, this is called a reverse voltage. If you are increasing the reverse voltage, accordingly this what will happen, this depletion region will increases. What will happen? What is the extreme case? What will happen? This depletion region, this much width will fully occupy the complete diode area. That condition is called base width modulation. Okay, that is a condition, and that condition is called base width modulation. Base width modulation is the conditions at which the complete diode area is filled with what? Depletion region. That area, that situation is called, it is known as base width modulation. After that, if you increase, what will happen? Diode will rupture. Diode will rupture means diode will destroy. Every bond of the diode will be breaking, something like a, what he told, like a superconductors, right? It will start to conduct like anything. So semiconductor is immediately changing its chemical property and it starts to conduct the current. Okay, so once we plot the graph for this, what will happen? We have a plot will be here, and this is again the current versus the voltage graph. Okay, so what voltage we are giving? We are giving negative voltages. Earlier our graph will be here, positive voltage. Now we have changed the battery. Okay, but P and N will be the same, battery changed. So we are coming to negative. Once we come to negative terminal, there is a minor current will be here. Minor current, it is not zero. What is this minor current? Is due to minority carriers. Here what is there? Electrons are there in p-type, minority carriers. In n side, what is the minority carriers? Holes will be. So these holes will be repelled by the p-type. Here electrons will be there. These electrons are repelled by this negative type. So there is a minority carriers. This is like a forward bias. For minority carriers, this is forward bias because p-type contains electrons, n-type contains holes. For these holes are repelled by the positive polarity. Here what is there? Electrons, minority carriers. These electrons are repelled by this battery. So what will happen? Here minority carriers can easily move. So there is a minor current, and this is called minority current, or this is also called saturation current. Okay, minority current as well as this is called saturation current. So this saturation current will be there. So if your keep on increases, so during the time you have to see your depletion region is keep on increases and fully filled the region of your diode. Base width modulation happened. After that you are again increases. What will happen? A diode will rupture. Rupture means destroyed and current will start to shoot. And this voltage is called breakdown voltage. This voltage is called breakdown voltage. So at the stage of breakdown voltages, what is the size of depletion region? Depletion region is fully occupied. The diode says beyond that it cannot grow. After that diode is completely destroyed, means the chemical structure will change out. Okay, all the bonds are broken. Its nature itself will be changed. It's behaving like a conductor, like anything. After that, you cannot make it as a semiconductor. You will never get it back at a semiconductor. Semiconductor property, it's gone out of control. Okay, semiconductor property irukade. A semiconductor property loss aina breakdown will happens. Okay, how the breakdown happens I will tell you, but breakdowns will be happen at this voltage. A breakdown point, this will be going out of track. Okay, so what we have written? Reverse bias characteristics below, right? Positive terminal of the battery is connected with positive terminal of the battery is connected with negative terminal. Positive terminal of the battery is connected with N-type material, N-type, and negative terminal of the battery is connected. Negative terminal of the battery is connected with P-type material. Okay, next one. When the reverse voltage keep on increases, when the reverse voltage keep on increases, when the reverse voltage keep on increases, the depletion region width increases. Depletion region width increases. Depletion region width increases. Depletion region width increases. Next one, depletion region width increases as proportional to reverse applied voltage. As proportional to reverse applied voltage. As proportional to reverse applied voltage. Half next, as proportional to reverse applied voltage. Next point. After some time, the diode area completely occupied by the diode area completely occupied by the diode area completely occupied by depletion region, completely occupied by the depletion region. This condition is called base width modulation. Underline the word. This condition is called base width modulation. This condition is called base width modulation. Next point. When the reverse voltage increases, at some point of time, Diode undergoes breakdown, or in bracket you can write rupturing, rupturing. Diode undergoes rupturing. Diode undergoes rupturing. Diode undergoes rupturing. And this voltage at which current starts to increase tremendously. Voltage at which the current starts to increase tremendously is called breakdown voltage. Important. Is called breakdown voltage. Kitna?
Current, how will current will start increasing?
A diode breakout. Diode breakout kitna. We have full width will be there, right? Full base width depletion region full out. Further that also, if you try to improve, what will happen? What will happen means diode will undergo breakdown. Adu eppadi breakdown vandalo I will explain. Okay, that is my next topic. I'll tell you. Okay, will undergo breakdown. Draw the graph. Write down saturation current or minority current, breakdown voltage, current versus voltage. You can make it this as there we have written forward current, right? Here it is reverse current. Current negative alla, current should not be negative, current positive, current direction opposite ആയിരിക്കും comparable to forward direction. Forward ൽ മേലെ തന്നെ പോകണം, അതിന് നേരെ ഓപ്പോസിറ്റ് ആയിരിക്കും ഡയറക്ഷൻ കറണ്ട് വരുന്നത്. ഡയറക്ഷൻ ഉണ്ട്. Okay. So saturation current, minority current, 2 years back 2018, that is a question will be there. Saturation current is due to dash minority carriers, majority and minority. Okay, options they can create, right? So saturation current is due to minority carriers only. Because nalla chance irukku majority and minority both A and B. Ni both A and B 0, none of this idukella bhayangara demand. Saturation. Because a tendency is the answer where the high chance. Saturation current, it's also called minority current. Okay,